Hello, my name is Teddy Criscuolo, Executive Director of Admissions at the Amity Math Academy, and today
we're going to learn about factor theorem.
Yes, today, as my partner Jake has so eloquently said...
That's me! I'm Jake.
Yes, we're going to teach you in a short presentation about the basics of factor theorem.
In this presentation, you will learn how to quickly identify factors of an equation. You will learn the concept and usage of synthetic division. You will learn the factor theorem, and use these skills to simplify a polynomial equation.
Before we dive into the topics that my partner Jake has just described, we first must define and understand the usage of factor theorem. Factor theorem is used to link the roots and zeros of a polynomial equation. The definition of factor theorem is that if x equals a is a root or zero of a polynomial equation, then x minus a, in parentheses, is a factor. As you have probably learned, a zero or a root of a polynomial equation, or any equation, is the x value that when input into the equation produces a y value of 0. So when looking for roots of an equation, you first want to look at the constant term. So when you're given a polynomial equation and it seems unfactorable by your means, you're first going to want to start by finding the first zero, or root. So the way you do this, as I said, is you look at the constant term of the equation, or the last term of the equation. You look at for factors of that constant. I recommend starting with 1 or -1 because those are the easiest to work with, and then you plug those back into the original equation. Obviously, if you produce a y value of 0, you have found your first root or 0. After you find your first root or 0, you can then use this knowledge and knowledge of the factor theorem to use synthetic division in order to simplify the polynomial equation further. Synthetic division is one of the most vital parts to factor theorem, and I am now going to explain that to you now. Okay, so first with synthetic division, you start by lining up the coefficients of the polynomial equation in standard form, obviously, because we like to work in standard form, below a division line with the x value of the 0 on the left. The x value of the 0 is, let's say the 0 is 1, then the x value is 1. So you then drag down the first coefficient value to below another line, and then you multiply that number, hopefully 1, but it can work with any number, by the 0. And then after you get that, you line up that number below the next coefficient, add those two numbers together, multiply the number that is produced as a result of the addition, and then continue. At the end of your division, if the polynomial is a factor of the polynomial equation, then the remainder or the last value should be 0, and you should end up with 0. And then the new coefficients you have besides the 0 will end up being the new coefficients of the simplified equation.
Okay, so what we just told you was a lot to comprehend. So now we're going to do out an example to show all these insightful pieces of evidence that we gave to you, and to show you how to use them in an actual problem. So what we are going to be doing in this problem is we are going to try to find all of the roots of this polynomial equation right here. 30. Oh, okay, plus 30. There we go. Okay, so what we're going to do first is we are going to try to find a root of this polynomial equation using the factors of the constant term, like we just told you. So, starting with the factor of 1, like we recommended, substituting 1 in for x here, I can see that that does not get f of x or y to equal 0. So, that is not a root of this polynomial equation. So next one I like to try is just 2. So if we substitute 2 in for x, we can see that, yes, f of x actually does equal 0 then. So 2 is our first root. And using factor theorem, we can figure out that the factor of this polynomial equation is x minus 2, because it's x minus this root. So what we're going to do here for the synthetic division, I like to draw this sort of half rectangle right here and place the root in the top left of that rectangle. Then we just write out all the coefficients of the terms here. So this would be 1. This would be -5. This would be 11. This would be -25. This would be 30, the constant term at the end. So what we're going to do is first bring this one down. So that's 1. So then we're going to multiply 1 by 2. So we get 2. We write that there. Then we add these together. We're going to get -3. So again, you bring this first term down, the first coefficient of this term down, and you multiply this number by the root, the number in the top left, and then the number that you got, which 1 times 2 is 2, so bring that over here, and then you add these two numbers together, and you get -3. So now, -3 times 2, -6, 11 plus -6, or 11 minus 6, is 5. Now, 5 times 2, that's 10. -25 plus 10, that would be -15. And then -15 times 2 is -30, so 0. Now, I'm closing this off because this is the remainder right here. If your remainder equals to 0, then that means the number that you used in the top left here, right here, is actually a root of your polynomial equation. So that is very good. Now, the polynomial equation that we got from this now, which is equal to our first equation, is f of x equals, first write in the factor, x minus 2, this factor right here. And then, the polynomial that we just found is going to be 1 degree less than our original polynomial, so that would be cubed is 1 degree less. So 1x cubed, or just x cubed, minus 3x squared plus 5x minus 15. So just going across using all of these numbers and going 1 degree down each time. So what we did for synthetic division was we divided this original equation by this factor, and we got this polynomial. So obviously, multiplying this polynomial by this factor would get us the original equation. So this is just a rewritten form of the equation that we had at the beginning. Now, a separate piece of paper to continue. What we can now do is we can factor this polynomial here by grouping. So then, by grouping, see that this is x squared times x minus 3, because x squared times x is x cubed, and x squared times -3 is -3x squared. So now we do plus 5 times x minus 3, because 5 times x, complete the parentheses there. There we go. So 5 times x is 5x. 5 times -3 is -15. So now what we can do, factoring by grouping, again, if you are unsure of what I'm doing when I say factoring by grouping, I suggest you watch one of the other videos on our YouTube channel, AMD Algebra Academy. But here we have x squared plus 5 times x minus 3. There we go. Okay. So now we have all of the factors of our polynomial equation, and we can find all of the roots, as I said was the goal with this problem when it began. So if we set x minus 2 equal to 0 to find the root, it's plus 2 plus 2x equals 2. And that's the root that we started out with too. So that's good. So down here we're going to write all roots. So first root that we found is 2. Our second root, start with x squared plus 5, so x squared plus 5 equals 0, so minus 5 minus 5, x squared equals -5. And if we square root that to solve for x, we would get x equals plus or minus I square root of 5. Now, if you are unsure how I just found the root of this, the square root of this negative number, then I suggest you watch one of our videos on that topic, complex numbers and imaginary numbers. So, continuing on, we found that. We're just going to set our last factor here, x minus 3 equal to 0 to find the last root, plus 3, x equals 3. So, there you have it, the 4 roots of our original polynomial equation.
Thanks for watching. Like and subscribe for more awesome math content from Amity Math Academy. This is T. Chris and Jay Silly signing off. AAA, baby. God. Watching.